So, what is artificial intelligence? In order to answer that question, let's just have some fun and look at a few things that sure seem like they're artificial intelligence. And since this course is all about deep learning, let's take a look at the current things deep learning is creating. Perhaps we should start with the most ubiquitous, AI assistants. And what are they super good at? Voice recognition. You most likely have a smartphone, and it probably has one of the following AI assistants: Siri, Cortana, Alexa, Google Now. Even though these assistants are still sort of dumb, they are all very good at one thing, and that is speech to text. The level of accuracy in voice recognition that we've come to expect is only possible with deep learning. Now, next one, machine translation. This refers to language translation that is done by a machine. You most commonly know of it as Google Translate. Notably, the Google Translate app uses deep learning to do both language translation and computer vision tasks. You can take a photo of words written in one language, and the app will detect the words and automatically translate it. This is all done with deep learning and computer vision. So computer vision is another area of computing that has seen massive leaps due to deep learning. Not only are computers able to recognize objects in photos, they are even getting pretty good at identifying your doodles. For this example, I'm going to take you to this webpage, Quick Draw with Google. Quick Draw with Google is a project where you are trying to draw a doodle and a neural network is trying to learn to recognize your doodling. Here I have to draw a pickup truck in under 20 seconds.
I see square, or pillow, or keyboard, or suitcase. I see cruise ship, or purse, or shoe, or bulldozer. I see tractor. Oh, I know, it's pickup truck.
Coming back to our slides, let's take a look at style transfer. Style transfer is pretty much what it sounds like. The neural network will examine a style or art or medium of one source and transfer it to another source. Recently, a very exciting paper came out on arXiv with an associated YouTube video that I'll now show you called Everybody Dance Now. This work was done at UC Berkeley. So the idea is we have a source subject who's actually dancing, and we have a target subject who the computer made dance. So the source video shown in the upper left corner is the man who's actually dancing, and they recorded him for some number of hours. Then the neural network has to detect the poses and then transfer it onto the video with the woman and make her dance. So all the dancing that you're seeing on the target result is done by the computer. The computer is manipulating the images and creating a movie of someone dancing based on a source video. This is one very cutting-edge application of style transfer that has a lot of people excited. So, in all of those examples, we saw computers doing amazing things, but is it artificial intelligence or is it just deep learning? Or maybe that's what machine learning does? So in this lesson, I want you to have the following key takeaways. I'll teach you the relationship between artificial intelligence, AI, machine learning, which is ML, and deep learning, DL. These three terms are often used interchangeably by the media, but they are actually very distinct terms, and we need to understand the differences between them. Finally, what does it mean for a computer to learn? We need to answer this question as well. Let's take a look at a Venn diagram that explains the world of AI. The first thing to understand is that machine learning is a subset of AI. The next thing to understand is that deep learning is a subset of machine learning. Deep learning is performing so well in multiple verticals that a lot of people are pinning their hopes and hype on deep learning. So let's dive into the core ideas that differentiate machine learning and deep learning from the earlier AI theory. In order to understand the difference between machine learning and traditional 1950s era AI programming, we need to understand the difference between deductive and inductive learning. Let's take a look at deductive learning first. In deductive learning, you take the rules and the data, and you feed them into what you could call classical AI programming. The output of the program are the answers. We call this deductive learning because it deduces the answers by examining the rules and the data. Now let's compare that with inductive learning. In inductive learning, you take the answers and the data and you input it into something we'll call machine learning. Then the output of that program are the rules. We call this inductive learning because the program induces the rules by examining the data and the answers. This is exactly what we did in the first module when we figured out the rule about cash and credit cards. This distinction is the key difference between what we could call classical AI programming and machine learning. However, you should note, both paradigms are part of the field of AI, artificial intelligence. They are just different approaches to achieve the same results. We want access to all three components. We want access to the data, the answers, and the rules. What's important to us is that at the end of the day, however we've solved the problem, we have all the green stuff, all the blue stuff, and all the orange stuff. We don't really care what order we get it in. It's just sort of like picking the best tool for the job. So what is learning anyways? I like to think about this question before I think about what machine learning is. If you Google the word learning, you are served this nice definition: the acquisition of knowledge or skills through study, experience, or being taught. How can this definition be applied to computers? What does it mean for a computer to study, for a computer to have an experience? How do we teach computers? A computer experiences the world with data. A data set represents a set of experiences that were obtained via sensors, surveys, photos, recordings, or any manner of information gathering. How does a computer study? A computer studies by applying algorithms to its data. It learns from its experiences using algorithms to study them. How do we teach a computer? We teach computers by programming explicit concepts that we're aware of. This is often called domain knowledge in the field of machine learning. It could be something like telling the computer the force of gravity on Earth, or that blue is a darker color than yellow. It's something we decide to teach or tell the computer, rather than let the computer learn on its own. In the previous Venn diagram, we saw that machine learning was only a subset of artificial intelligence. This is true because the field of machine learning is specific to teaching computers to learn from data. Meanwhile, artificial intelligence encompasses both this practice and deductive logic, teaching computers to learn from rules. Now, specifically, deep learning is a type of machine learning algorithm. So, why is it called deep? Deep learning utilizes many layers that operate as functions. Earlier neural networks also used layers, but just not very many. Today, advanced deep learning networks will have hundreds of layers. It's called deep just because if you think of the layers as a stack, they're much deeper than previous generations of neural networks. Each layer can also be thought of as a depth of abstraction. You can think of each layer as learning one part of the rule, and together the layers add up to make a complete set of rules. This is also called hierarchical learning. The lower layers build up to the higher layers, and altogether the machine can hopefully learn abstract ideas. We aren't sure what each layer is learning or how it all fits together. This is still a very active area of research. Deep learning is often considered to be a type of black box, which means we only know what goes in and what comes out. It's impossible to understand why the deep learning model made the decision it made. This is very much an active area of research to understand how deep learning models make their decisions. I'd like to convert some of the plain English I used to start this module into terms that are commonly used in the field. Also, this will provide you with a richer understanding of what deep learning is doing. We saw earlier that inductive learning is when we have answers and data, and we pass them into an algorithm, in this case, deep learning, and it learns the rules. The answers are actually called labels, and the rules are really mathematical functions. The functions are learned through a mathematical optimization process. And what we're really trying to do is attempting to approximate a universal, quote, true f of x for the problem that we want to solve. Basically, when we make a cat detector for videos, we want to solve for the mathematical function that takes as input any set of pixels and provides as output the answer, it's a cat or not. However, since our deep learning models learn by induction, they learn by looking at the labels and the data, They are limited by their inputs, which is very specifically the data. It's impossible for a deep learning model to learn how to identify animals it has never seen before. So, let's do our conclusions. Deep learning is a subset of machine learning. Deep learning is inductive learning. It learns functions from data. The deep in deep learning refers to many layers in the network. It also refers to hierarchical learning, or the many layers of abstractions the network contains. Deep learning is an optimization problem, and all optimization problems are limited by the data they optimize on. In our case, this means deep learning is limited by the input it has, the data it's provided with. I hope you enjoyed the video. In the next module, we'll take a dive into data. What is data, and how important is it for deep learning?